Hey guys, today we are doing Unit 4, Lesson 6, and it is on trigonometry and trigonometric ratios. I'm going to break this video up into two smaller videos, and we're discussing things kind of in three different parts. So our first part is just getting accustomed to knowing what the trig ratios are and how to find them. So what is trigonometry? It is the study of triangle measurement. When we talk about measurement, we are referring to side lengths as well as angle measures. All right. So let's start with our very first one, sine. It is in pink. The sine ratio is the leg opposite of the angle to the hypotenuse. All right. The cosine ratio is of the leg adjacent to the angle to the hypotenuse. So adjacent means next to or right beside it. Adjacent and opposite both will change depending on which angle you're discussing. However, the hypotenuse is always going to be the hypotenuse no matter what. And I did highlight that over here in this little image. Okay, remember the hypotenuse is the side opposite the 90-degree angle. So when I'm referring to hypotenuse, that will be the same in both sine and cosine because the hypotenuse is always the hypotenuse. And then we have our tangent. That is the ratio of the leg opposite the angle to the leg adjacent to the angle. So let's use this little example here. Now, I have angle A as red and angle B is orange, okay? And I'm going to zoom in just a little bit. So we don't ever need to know or find out angle C because that's our 90-degree angle. So we already know what that is, all right? So I am going to do A, which is red. So the side opposite angle A is side A. This is opposite. Okay, so I'm going to put an O for opposite. The hypotenuse is always the hypotenuse. And then for angle A, which side is adjacent to it? It is the side touching the angle. That's not the hypotenuse, okay? So it's the other leg. So this is the adjacent red side. This is the opposite red side. I may need to get a different color. Okay. So let's come over here and fill in all of our ratios for sine, cosine, and tangent just for angle A. Okay. So one way that you can help to remember is SOHCAHTOA. SOHCAHTOA. So this helps you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and your tangent is the opposite over adjacent. SOHCAHTOA. You may also be able to Google search SOHCAHTOA and ways of remembering what order these go in, and you might find some other fun ways out there to remember this as well. So let's start with finding our sine for angle A, which is the opposite, which is side A, over the hypotenuse, which is side C. So this is A over C. Okay. Now let's do the cosine cosine for angle A. It is the side adjacent over the hypotenuse. So angle A, the adjacent side is B, and the hypotenuse is still C. So B over C. And now our tangent. Our tangent of angle A is going to be the opposite side over the adjacent side. So A over B. Now, we're just doing an example with variables. We will have numbers when we start to actually solve these, okay? Right now I'm going to do my orange sides or angle B. So now I'm working with a different angle. The hypotenuse is still the hypotenuse, but what is now the side opposite this angle? Opposite this angle is this side B. So this is opposite now the orange angle. And so that's opposite, that's hypotenuse. This is the side that's not the hypotenuse, the leg touching angle B. So this is adjacent to B. So there's a reason that I used colors, okay? Orange goes with orange, red goes with red. So now let's go through our SOHCAHTOA again for angle B. So let's do sine of angle B. Sine is opposite over hypotenuse. So opposite is B, hypotenuse is C. So B over C. Cosine of angle B. Cosine is adjacent over hypotenuse. So A over C. And then finally tangent. Tangent is the opposite over the adjacent. So opposite is B, adjacent is A. So B over A. All right. And if I zoom in here, whoops, I meant to zoom in. These are my ratios. Again, I only need to do it for the two angles that are not the 90-degree angle. All right, so notice the similarities here and the differences. So the hypotenuse is always the hypotenuse, but the side opposite or adjacent a specific angle changes depending on the angle that you are using. Okay. Let's come down here and I want you to practice. Okay, let's try this. I'm going to zoom in. Now we actually have side lengths here. So we're going to be able to use these side lengths, okay? So sine of A is opposite over hypotenuse. The side opposite angle A is 5. So that's opposite angle A. And then the hypotenuse is 13. So this is the hypotenuse, 13. All right, now let's do the cosine. So I need the adjacent over the hypotenuse. The leg that's touching angle A is the leg that's adjacent. So that's 12. So that's 12 over the hypotenuse, which is 13. And let's do it one last time for our tangent function. Remember, or the ratio. The tangent ratio is opposite over adjacent. So opposite is 5, adjacent is 12. Okay, and the instructions do want us to put these in simplest form, but all of these currently are already in simplest form, so I'm good to go. So why don't you take just a moment and see if you can fill in these ratios for the orange angle C. Okay, now I'm changing colors and I'm working with orange. So the leg touching angle C is what's adjacent to it. So this is adjacent to angle C. The side opposite C is 12. So this is opposite the orange. And see if you can use this to fill in sine, cosine, and tangent for these. Zoom out a tiny bit. All right. They are in simplest form. Let's look at example 2. There's a little problem in example 2. I only know 2 of the side lengths. So what is it that we know about right triangles that can help me determine the missing side length? So let me come over to the side here. Guys, we know the Pythagorean theorem, right? The sum of the squared legs equals the hypotenuse squared. So A squared plus B squared equals C squared. I'm going to plug in 9 and 12. It gives me 81 and 144. And then if I add those together, I get 225. And then I'm going to need to square root that. So the square root of 225 is 15. So this side length is 15. All right. Now that I know all 3 of the side lengths, I can go ahead and fill in my ratios. So starting with red, W. So this is the hypotenuse. The leg touching W is adjacent to it. And then this is opposite W. So let's go ahead and fill in these ratios. For sine, I get opposite over hypotenuse, which is 12 over 15. And I do want to reduce this. It'll be 4/5. They both were divisible by 3. Let's do my cosine. Adjacent is 9. Hypotenuse is still 15. And then let's reduce these by 3. Get 3/5. And again with our tangent, opposite over adjacent, okay? Which is going to be 12 over 9, which does reduce to 4/3. Okay, so we have done W, the red angle. Now I want you to do X, okay? The leg touching the X angle is adjacent to it. The hypotenuse is always the hypotenuse, and the side opposite angle X is 9. Starting to run out of ink in my pens. All right, so go ahead, and I'd like for you to fill in the ratios and to reduce them for the X. All right, guys, so here are my answers for angle X. Sine is 3 over 5. Cosine is 4 over 5. Tangent is 3 over 4, right? Now I'd like for you to pause your video, and I want you to try example 3 all the way from start to finish without any guidance. And let's see if we can correctly identify opposite, adjacent, and hypotenuse for each of the angles and fill in the ratios over here. Just be aware that you do have one missing side length, so you will need to figure out what that is. So go ahead and pause your video. All right, guys, welcome back. For example 3, the very first thing that I had to do was use my Pythagorean theorem. So I did the hypotenuse squared minus the leg squared that I know, and that's going to equal the missing leg squared. Okay, just use your calculator to help you quickly simplify this. You square those and then subtract them, and you get 900. The square root of 900 is 30, so that side length is 30. I did label my red and orange adjacent and adjacent and opposite sides. And just remember, the hypotenuse is always the hypotenuse, okay? And so let's scooch this over, and these are my ratios. Be sure that you simplified them if you could, okay? And so I'm going to go ahead and show all of these. Now my orange ran out on me, guys, so I had to switch over to using my black pen.